One of the most missed topics on your week 8 quiz was based on the application of exponents. So I wanted to hop into this learning module here to highlight a few things for you. Okay, so the topic on the quiz was about a brand new car and how over time the value of the car will depreciate. So that stems from this function right here. Okay, this one that I'm highlighting. So when you're given an equation already done and you're seeing, for example, in the parentheses, the 0.87, what that means is the rate that the rate was already applied to the problem. So when you look at that 0.87, you need to think to yourself, how did that 0.87 get there? And it got there by doing 1 minus 0.13, right? 1 minus 0.13 would be 0.87. And when you're subtracting a value, that tells you that your rate is decreasing versus what if it was 1.87, something larger than 1? That would mean you're adding on a rate, which means you're actually growing exponentially. All right, so if we know that the rate is 0.13, translated to a percentage, that would be 0.13, that would be 13%. What that means is every year the car loses 13% of its value, right? So after year 1, it's now 13% less. And then year 2, it's another 13% less, so on and so forth. The other alternative you could say is every year the car will hold 87% of its value. So that's another way to interpret what that 0.87 is. So hopefully you found that helpful. Something that was not on the quiz, but it might be on the exam and definitely might be on the final, is the difference between the two exponential functions. So you can see this one up here where you have either 1 plus a rate or 1 minus the rate, compared to this one down here where you have a base of e. E is Euler's number. Okay, Euler's number is kind of like pi. It's an irrational, never-ending number that appears a lot in mathematics. Why it appears, that's a story for calculus. But when to use which exponential function, right? So if you're given an application question and you have to decide which function to use, how do you decide? Well, it's all based on this word continuous. If the question is describing a continuous rate of growth or rate of decay, that's when we want to use the function that has Euler's number in it. So if you take a look at this video down here highlighted in pink, you can see the word highlighted continuously. Same thing with this one down here, continuous interest. Anytime you see the word continuous, we want to use the Euler's exponential function. In comparison to if you don't see a word continuous and it just says you're increasing over time. Now, over time could be a period of weeks, days, hours, years, however they describe that time. Then you want to use this function here. So hopefully you found this helpful. The other topic I wanted to reiterate was on your Desmos activity. On the Desmos activity, a lot of you are having trouble identifying the transformations and what each type of transformation does. That goes back to week number 4, function transformations. This chart, understanding what it looks like when I'm giving you a function, what it actually means, and then how it affects the ordered pairs. That all is here in the chart. I'd like you to take a look at it and revisit that topic. And there's 2 example videos above that remind you how each of those transformations will affect a function.